Hi, I'm going to talk about an assignment which I worked on recently using the SVM model, the support vector machine model. The objective of this assignment was to identify a digit based upon the various pixel display values. So identify Arabic or numeral digit of that. So basically a model using the support vector machine which should correctly classify the handwritten digits based upon the pixel value given as features was to be developed. So that's the objective. Coming on to the data part of it. So the data was sourced from an MNIST data set. That's a very large database for such kind of information there. The data was in form of a zip file which was downloaded from the source location, and then it was merged for this analysis purpose. It had close to 70,000 rows records and had about 784 attributes in it. 784 is derived as 28 times 28, that's the pixel value for each digit. So that's the 784 attributes for each digit what it was in that data set. So once the data was loaded, the next exercise was to do a data cleaning there, analyze the data. As part of that, we had a column there, the first column which had the digit value there, which was renamed, and post that looked for any missing values or duplicate records. No such observation was there. Then looked for any rows where all the values are 0 or sum equals to 0. Such records, if any, were to be removed. Where all values in the column are same, because that doesn't give any variation to us. So after all this data cleaning exercise, the next step was to work on the model building. Going by the standard practice, the data was split into 70:30 ratio, where 70 belongs to a training data set and 30 as a test data set. It was split into. Further, a split ratio feature was used with a value of 10%, given the high volume of data that was available for this analysis. As part of this exercise, two models were developed here. First model was the linear model. Using the linear kernel, it was prepared here. And once the model was developed, predicting the model results, prepared a confusion matrix which showed an accuracy of 0.90, sensitivity of 0.90, specificity of 0.98. That was for the linear kernel model. Similarly, for the same data set, another model was developed using the RBF kernel. In this case, the confusion matrix result was 0.95 for as accuracy, 0.95 for the sensitivity as well. The specificity was 0.99. The figures here, the RBF kernel seems to be better than the one that we got for linear kernel method. Post this, the hyperparameter tuning and cross validation was done here. And a cross validation using the tenfold with a method SVM linear was done. The accuracy in this case was 0.90. So it was done for a various values of C's from 1 to 5. Accuracy seems to be the same for all the C values. Again, this was now tested on the test data, for which the accuracy was 0.90, sensitivity was 0.90, and specificity was 0.98. Based upon this, the conclusion arrived was RBF kernel shows better accuracy than linear.